Yeah. After some around months of silence, what's going on, Igor? How is everything?
Everything is good. Thanks for asking, Alex. Yeah, it was really a big pause of silence. Nothing came from our side. Apologies for that. We're back, and hopefully today we're gonna engage you and start doing it regularly.
Yeah.
And it's Sunday, yes, and today we might have some issues.
We do, yeah. So in case of any problems with the internet, we might stop the stream a bit earlier than usual, let's say. But we also have a challenging goal today. I think Igor will explain it in a bit. And for now, I have a head to show, which I'm gonna do right now. Here we are. So Igor, what we gonna do today?
Yeah, so today we decided to work on some machine learning project. So we went to questions that are already closed and that look not very complicated to make it in 40, 50 minutes. And we found one about the horses. So to be honest, I'm a bit afraid to switch the tabs in my browser, but I have to do at least one switch, so bear with me.
Let's hope it works.
Uh,
Yeah, it
I,
did
I
work.
hope I'm
Everything's
back. Yeah, I hope I'm back. So I probably yeah, I won't switch to the page of the competition itself, but basically it is the data set about the horses. So I think the horses have some like how big they are, how fast they are, what's their temperature, and so on. And somehow the task of the data set is to predict whether they stay alive. I don't know what they are doing with these horses, but basically it's depending on their current status, we have to say if they're alive or not.
All right.
And
Yeah.
I just downloaded the data. Yeah, I just downloaded the data, so I haven't looked, and Alex also hasn't looked into this. So and we see what's in there. So for this, we will need the usual tools of any old school data scientist, not like um, the old tool like pandas. So I'm gonna import pandas. And so SQL for Python. And oh yeah, I have to pick the kernel because I just restarted my kernel. And we picked it. And now we should import pandas.
Kernel is a Python interpreter,
Take some
or
time. Okay, so we did import it, and now we want to. Yeah, exactly, because Jupyter is like the way to run the Python scripts, and behind under the hood, I just restarted this Python process, so that's why we have to reconnect to it. Yeah. Okay, so for now we can just I suggested we read the data, show it, and just go quickly through it. And for this, I think Kaggle gives us the data split and train and test. So we do the usual command read CSV, and it should be in the same directory. It's called train. Actually, read test in one line just to save a bit of time. So the files should be small, and let's see how it looks like. Okay, so I don't know if it's big enough, or maybe I should make it bigger.
it looks good to me. Thanks.
Like this. Yeah, so basically what we see here, so there are just 1,200 columns, 1,200 horses to train on. And what do we have for them? So the ID is just that they had a surgery, if they're adult or young, some hospital number. I'm not sure how useful it is. Rectal temperature. So, and yeah, basically some other. Maybe I just transpose it to see all of them. Oops. Just like this. So yeah, different things like different respiratory pulse, peripheral pulse. Yeah, different things that I don't really understand. Peristalsis. But there are also a lot of different medical features. And based on these features, yeah, there is a last column, outcome. Oh my God, that's so cruel. So
Yeah.
there is the outcome lived, yeah, died, euthanized. Actually, we can see what are all of them.
It's a bit surprising that I don't see the age column. Do you see that, or it's intended not to be there?
I just scrolled from it, so the age is here. But
Yeah, I mean
basically
the
says
age like a number. Yeah.
yeah, it's a bit weird. Maybe they think that it's not important, or maybe they think that it will be too easy if they give us the age. I don't know. Yeah, but yeah, it's a bit weird. So we have a total protein, but no age. Whatever. Yeah. Oops. Yeah, let's see what unique. Yeah, so it's basically 3 unique values: died, euthanized, and lived. And yeah, I thought that it's a binary classification task. So when you have like 2, like lived or died, but we have 3 of them in here. And I think I have to switch on the div to see how the task is formulated. So please bear with me. I'll be back in 10 seconds.
Okay.
Okay.
Thanks for letting us know up front. Okay. Yeah. So far we are with you,
I'm
and
with you,
you are
right?
with us. Yeah.
Perfect. Okay. Yeah, I see. So yeah, it's a multi-class classification. And for this, we have the metric of micro average F1 score, whatever. So yeah, we basically have to predict these 3 outcomes: lived, died, or euthanized. Although we don't say it directly. Predict corresponding outcome, header and header following format. Okay, yeah, so it's not a usual classification task, let's say. For me, it's a multi-class classification. Yeah, it's even tagged. So I'm switching back. Yeah, so I guess we should start from simple things, and from a very high level, we have different features, and the features are of 2 different types. They are either numerical, or they what's called categorical. I think, yeah, I already forgot. So they consist of categories. Yeah, and these kind of features have to be tackled in a different way. So we can start small and take a couple of features of both types and see how it goes. So I don't know. So we can say that we want to use. So we are now gonna build a small machine learning model, and we'll see how it works, and then we would try to improve it. And the very basic machine learning model will be based on, I don't know, 4 features. Let's say, let's pick the easiest ones. I don't know, the first, rectal temperature and pulse. So I will just create features in how it's called, numerical, and I put rectal temperature and pulse, and let's create features categorical, and put Yeah, now H and peripheral tools. Well, actually, yeah. Okay, so so we can actually start even with only numerical features because we don't have to process them most likely. So let's so we have our terrain. Actually, test looks exactly like this, right? Like terrain. Oops, I think it's called data test. Yeah, so data test has 800 columns and data train 1200 columns. CP data. Yeah, actually, so here test doesn't have the outcome column, so we are supposed to predict this data. Yeah, so that's why for now we're not gonna use it because we will use it only when we want to submit our results to Kaggle. Now it's of no use to us. So what we're gonna do now, we will split our initial data set. I will call it data. Yeah, and now we're gonna split it in train and test because we need to train on something and to check how good we are. And for this, we will import from sklearn. I always predicted, I think it's called terrain feature selection import. No, I was wrong because there are some vacuum feature extraction.
Is it a concrete model, sklearn, or it's some utilities?
It's some utilities. Yeah, I now want to import some methods which split the data set, and I always forget where they are. Maybe model selection. No, yes, yeah. So it's in model selection. So there is a function train test split, and we can import it. And now we data train data test equals. It has. So we put the data, and we say how we want to split. So we can say test size equals 0.2. And it's also a good thing to do the random state, to specify the random state, just to do it the same always. And we can define the seed as 42, of course.
Yeah.
Yeah. So now, yeah. So now we have the test shape. Yeah, now we have two data sets, like 1,000 of them of the points are in train and 250 in test. And now we can do something. So yeah, let's see data train. Let's see how these features, numerical features, look like. Features numerical. So it's just a subset of two columns. And so what we are actually interested in with numerical features is if there are empty values. So if all of them are filled, or maybe there are missing values. So we can do isNA, and it shows us for every line whether it's a missing value or not, and we can do the sum. It will show us. Yeah, so there are basically no empty values. It shows us that there are 0 empty values for both of them. That's good that we don't.
They are all non-empty.
Yeah, exactly. Yeah. So that means that we can already use them for some model, and we can actually, we can import some model from sklearn. So we don't have to build the models. So the models are already coded for us in sklearn.
Are we gonna need to do these iterations like we did with the deep learning exercise, like define layers of a network and define the loop going through a number of epochs, right? That is called.
Yeah, in this case, it's a bit different. So I could say it's simpler because in case when we don't use deep learning, we don't define these epochs and so on, and we don't have to. So every model, we don't have to define the layers. Every model is already quite simple, and it is coded in sklearn, so we just use it.
Okay.
So there is no need to do anything. And we could also apply deep learning methods to this task, but the data is not. So there are quite a few data points, so I'm not sure if it makes sense because usually for these sizes it's not feasible, but not meaningful, let's say. So we can start from the easiest classification model, which will be the logistic regression. So that's the most basic model. So it is a regression, so it takes all the features, it puts the coefficients to the features, tries to fit these coefficients, and then so when you have the feature and the coefficient, you multiply each feature to each coefficient. Maybe if I can do, I don't know, coef1 times feature 1. And so on and so on. So it goes and multiplies all the features with coefficient, and then you have one number after it. And then you convert this number into some probability by the logit function. I don't remember by heart, and I'm a bit afraid to open the tab. But I think it's something like 1 divided by 1 plus exponent of minus k, where k is this. I might be mistaken, but I think it's something like this. Maybe not once. Yeah. And basically it converts the k. So k is from minus infinity to plus infinity, and this transformation puts it from 0 to 1, which because it's classification. Okay, so let's import this thing. I think it's in linear models. Import logistic regression. Yes, that's right. Now we have logistic regression imported. And the easiest way, we just initialize it. So we say model equals logistic regression without any parameters. Let's just go like this. And now we say let's build our data set for training. So we also need to define the target. So target is the outcome. I think it's called outcome. And now we just built our, usually the features data set is called X. So we can call it X train, data train feature X test. Okay, so
Igor is a bit broke right now. Let's, yeah, you're back, it feels like. Yeah.
Hello.
Hello, hello. Yeah, it's not perfect as you can imagine. Let's put it that way. Sometimes we can hear you.
Hmm.
No, no, wait, wait. I think it's better now. We can go on, I think. At least I saw some movements, yeah.
Yeah, I can.
Mhm. Yeah, let's do the run. Let's run the model.
I will try to reconnect to my mobile.
A suggestion might be if the connection doesn't go back soon, I think we can do this time a little bit shorter, maybe half half an hour would be the this time event, and then we can continue next week or whenever it's better suitable. Let's wait. Maybe Igor will rejoin in a bit. Igor, looks like your connection is better. Is it?
Am I really back, or it just seems like?
You are back. The screen is black though.
Black screen. Let's have try to share it then.
Back in black, you know.
Black and black.
Yeah, yeah. Now we have it.
What about now?
Yeah, yeah, all good.
That's perfect. So now we have great. That's really nice to hear. So I think when you
Hmm.
lost me, I was writing this cell.
Yeah.
So we are creating, yeah, we're creating the set of features for train and test and the set of targets for train and test. So we just sub-select what we wanted. Let's run it now. And now we initialize the model, and the only thing which is left is just to feed it to train the model. And basically all the data science is like this. So we feed it, and we have to specify the features, which is our X train, and the targets, which is our Y train. So now we run it. and we have a trained model.
Yeah.
So now the model has some, I don't know, we can look at for example. So you see it fitted some of the coefficients, but what we want it to outcome to give us the predictions. So for this, there is method predict. Actually, you see that we can predict the class. So we have 3 classes, 0, 0, 1, 2. We can predict them. We can predict the probabilities, and we can predict the log probabilities. I suggest we look at the probabilities. Oops. Okay, predict proba, and we have specified the set of features we want to use. So now we specify the test features. And let's call it predictions. And it looks like this. So you see we have, so every data point has 3 values. So because we have 3 different possible targets, and we have around 250 data points. So for every data point outputted the class, so it outputted 3 probabilities of different classes. Yeah, and now it's a bit of a different things that we can do, because with 2 classes it's a bit easier. We have 2 numbers and we just take which one is bigger, let's see.
Yeah.
Here we can do different things. So basically the easiest way is also to take the one which is bigger. So for example, here it will be the last class, and here it will be the first class. But we could also do different things. We can say, for example, that we want our probability to be at least 70% like this, and only in this case to output the probability. Otherwise, say nothing. I don't know.
Okay. And
yeah.
In this strategy, how we deal with the unpredicted ones, like we just keep them in the exercise. So in the end, we gotta come with something else to this.
Yeah, that's a very good question, because basically for this exercise we cannot skip the prediction. That means that we have to deal with it. So like in real life, if you want to do some, I don't know, predict the segment of the customer, we might skip the customers, because if we're not sure, it's better not to do something with them.
I see. Yeah.
Yeah, but in this case, we can just use the typical thing. And so we can take the max, and we can actually use the method predict, because it will just output us the max, and we can check it. If we want, let's call this proba, and this one will be just predict. Yeah, and let's just look proba top 5, and that's top 5. Yeah, so basically leaf died. Yeah, so actually we don't know what is the order, so which is live, dead, and so on. I think it should also be somewhere specified in the model. Classes, yes, it should have. Yeah, so basically this is a set of classes. So 0, 1, 2. So 0 is died, 2, 1 atomized, and 2 is lived.
Yeah.
Yeah, and we can compare. So for example, in the first, the winning class should be this, so the 2, so lived, yes, and we see it lived. And this one, this class, it's died. We see died. Yeah, so it kind of works.
Yeah, it kind of works. It looks like that. Yeah.
Yeah. So yeah, we can give up on this. So we have the first model, and so predictions look like this, class look like this, and now we can check how good we are in these predictions. So we have the true values, which is y test. Yeah, 25. So the first 5 values, we see that we out of these 5 we guessed only one, the last one. The others are not correct by us. But we want to kind of check it numerically. And for this, there are different metrics. And as far as I remember, there is some metric. I forgot it, so I have to switch again. So please bear with me.
Okay, I will show head in the meantime.
Okay, so micro averaged F1 score. Yeah, head is nice. I hope I'm still with you.
Yes,
And let's
yes.
switch back. Yeah, so we need an F1 score micro averaged. So F1 score is a metric. It consists of precision and recall. It's some combination because in classification models, you classify either it's happened or not happened. And based on how you balance the model, you can have either more, okay, if someone has died and you're trying to predict whether the person has died, you can say that everyone died. So in this case, all your predictions, so you will predict everyone who died, but you will also have a lot of false positives. That you said that they died, but they did not. On the other hand, you can say that no one died. In this case, you will have a lot of false negatives because you predicted a lot of people who have not died. And it's always a balance of false positives and false negatives. You cannot optimize both of them. So you can optimize only to one of them. And for them, there are two different metrics, precision and recall. I think precision is a way to decrease the false. I might be wrong, but let's say it's like this. So the one is focused on false negatives and other on false positives. And F1 score, it's a way to combine both of them. It's something like false positive times false negative divided. Actually, it's divided by their. I think it's like this. So geometric mean, it's called. So it kind of tries to optimize for both of them at the same time. So in my practice, like in real tasks, it never works. So I prefer not to use F1 score ever, because you usually need either false negatives or false positives, and it doesn't make sense to try to optimize for both of them in my practice. But here they want us to do it, so let's just import this metric from sklearn. Everything is already calculated for us. So from sklearn metrics, import F. It's actually called F1 score. Yes, F1 score. F1 score, and now we can calculate it. F1 score, and it takes two parameters, the true and the predicted. So the true is our y test, and the predicted is threats. So we also have to do the micro averaged, because when you have more than two classes, there are different ways how you can calculate this, because false positives and false negatives, they exist for three different classes in our case, not only for two. So there is a different way to aggregate them, and I'm not sure which is the default one. Average binary. Yeah, so average, this parameter is required for multi-class. Yeah, we need the micro averaged, so we need this one, micro. So we have to specify that average equals micro.
And that will give us a number how precise our model is, right? That's the idea.
Yeah, in a way, yes. So it will give us some number which shows us how good our model is. But the bad thing is that this number is not really explainable, because it's a mix. It's an aggregated mix of two different values. So when you're dealing with a real task, it's really hard to use this F1 score because it just doesn't give you a grasp of what you're doing. But we have to do it. And,
Okay.
Yeah, we can call it metric. And let's print it. F1 score equals metric. I think it's like this, just to show the first 4 values after the comma. Yeah. So it's 51%. I have no idea how good it is. But we can actually look at the leaderboard of this competition. Leaderboard. Okay, we see that the top score is 78%. And I don't know if we see. Yeah, okay, so you see that the most of the people who apply, they have 75, 76, 78. So we are much lower, which makes because we use just 2 features and the easiest model.
And at the time, you can say we have to use a logistic regression, right? It was just the first choice for the model, right?
Yeah, it was just the easiest model, so we don't have to use it.
I see.
So for now there are 2 things that how we could do. The first thing is to add more features, and the second is to try different models. And so I suggest that we quickly try to add a bit more features and keep the model the same. And just what are the features? I can do this. Okay, let's just add a bit of more numeric features because we don't have to process them. Let's packed cell volume, total protein. Total protein. And see whether it changes something. So I just rerun these cells, reinitialize the model, retrain it.
Nice.
Repredict. So this one I will delete.
In your practice,
by the way,
it makes sense to add all the numeric features, all the features that we have. Oh wow, that's a cat.
Yeah, so that's a new guest of our videos because it has to be shown. So it's a very nice kitten that I have currently at home.
It's very cool.
Yeah, so let it be. In practice, yes, it makes sense to generally, yeah, it makes sense to add all of them, and actually we can process them in a bit different way. So, like for example, if we have like salaries, which goes from 0 to infinity, it makes sense to put not the salaries but to log scale them because it will make more sense. So, and we can do these procedures in a different way for different kinds of features. Yeah, but for now, yeah, let's see. I think I ran the predictions, and let's see the new metric. And they can actually keep this one. So 2 features. 2 features. And these 4 features. Yeah, you see, we added 4 features. It's already 62%. It was 51. 62. So it kind of looks easy now. But it won't go like this very always. So there will be some plateau. So at first it's really easy to improve the model, but yeah. So yeah, you're right. So maybe let's try to put all of the numerical features. And for this, so in real tasks, I prefer to specify them explicitly. So say like this, even if we have 100 features, I just put all the config file and explicitly put them. But in our case, I think we can do something like dtypes. So for dtypes, and we can go through them. If it's a float, yeah, it's not that easy because the age is specified as object.
Yeah, I guess objects are categorical and rest are numerical then.
Yeah, it's supposed to be like this, but the H in our case is not categorical, it's numerical.
No.
So
It's like adult or
ah,
yeah.
you're right. Yes, exactly.
Mhm.
Exactly. I thought that it's not showing. So yeah, we can basically create list num features, and let's just iterate in all the features. If yeah, is it? Property. If yeah, actually it's let's do maybe like this. Yeah, I'm trying to understand what the types returns us, whether it's
type of result.
yeah, okay, so it returns only the result, but I guess it has indices. Index. Yeah, it has index. I'm trying to process it. Oops.
Mm-hmm.
So I think so if feature type equals, yeah, I'm not even sure if I can do like this. I probably cannot. So let's at least print it. Print. Yeah, okay, we have probably to output the index just to know which one to take. Print the data train columns index. Yeah, so it's integers, and we need floats, right? Float. Yeah.
Looks good.
Okay, so yeah, actually we can keep the integers as well because we need just numbers.
Yeah. Objects category, and the rest is numbers.
The only thing that so I just let's rerun it for integers, and it shows us 5 features. So, but the first 2 are ID and hospital number, and ID is not a meaningful feature; it's just an index. And the hospital number, I don't know, but I guess it's not useful for us for now.
True.
I actually see that there are the same values. And basically, actually, oh wait, but how can it be? Well, if the outcome is the same or not? Yeah. You see, that is kind of a small hack for us. Because we didn't know that I thought that every line is one horse. But I guess the same, the same hospital number means that these are just this is the same horse in different periods of time. To be honest, this is not how the data set should be constructed. And I suggest we don't use it because it's just some either a broken data set or the way to cheat. I don't know. So I suggest not to use the hospital brand ID, but we can use this Lesion. I don't know what's Lesion. So let's do like this. Well, 64, and yeah. Okay. Yeah, I guess let's quickly try to do this, and I guess we'll stop. We'll stop. So I will just do append. Yeah, now we have the list number of features, and this list number of features. I think it's called remove. Yeah, okay, I don't remember exactly how to do it, so let's just create a new data set without these features. Or let's put them in here. So it's a bit of manual work.
Yeah, it's okay.
Yeah, and it's ugly, but whatever. And let's rerun our model and see how it changes the data. So again, we re-identify the model. You see now it shows there might be some issues with convergence, so it did not converge, but it's just a warning, so who cares? And let's see now how it did change. I think now we have around 8 features. Yeah, I see it's a bit worse, which might also happen because maybe some of the features that we put, it's misleading, or this we should look into this. Why it did not converge?
Interesting.
Yeah.
Igor, awesome exercise. Actually gave me a lot of interesting material to observe.
Yeah. So yeah, next time we can go on with this kind of stuff. Maybe I could be a bit more prepared to just guide you through it. Yeah, and sorry for this connectivity issues.
It was awesome. Anyways, again, sorry that we've been silent lately. We will try to fix it. Have some, no promises, but we really hope so.
Yeah. So yeah, you all guys, please do follow us. Bear with us. We're gonna make you happy and ourselves as well. And yeah, keep it up.
Yeah, have a good Sunday, everyone.
Yeah, have a good Sunday.